Hi everyone, it's session 5, and this session is about searching for extrasolar planets, or planetary systems outside our own solar system. Remember I told you that before 1995, 23 years ago, there were no extrasolar planets known of. And since then, we've discovered thousands of them. So how have we discovered all these planets and star systems with planets? So astronomers use evidence. We can't go there and touch, so we have to find evidence through what's called electromagnetic radiation, the electromagnetic spectrum. We look at light, but not just the light we can see with our eyes, light waves or electromagnetic waves that include X-rays, ultraviolet, light, microwaves, radio, the whole spectrum. And when astronomical objects emit that light, they emit light according to their temperature or the processes that are going on to create the light, but also they might absorb light if they have atmospheres around them, or if like a star has a chromosphere, a layer around it that has cooler gas, and light passing through that, some of it gets absorbed by that cooler gas. Anyway, it creates what's called spectral lines, patterns, and we can see those patterns from stars. So now, if there's a planet moving around that star, the planet's going around, and the planet has mass too, so the planet's causing the star to shift back and forth a little bit. It's wobbling with the planet. So let's just focus on the star that's wobbling around. As the star moves towards us, its light gets crunched up. Light always moves at the same speed, but its wavelengths get compressed. And as it moves away from us, the wavelengths get stretched out. So this light pattern that we're seeing from the star is getting scrunched and stretched and scrunched and stretched. And that's causing what's called the wobble effect or Doppler effect. We can look at the change in the lines that we see. And if they get blue shifted, they're compressed. And if they get red shifted, they're stretched. And that tells us the motion of the star. The star is wobbling back. We can look at the period with which it wobbles, and that tells us the period that the planet is orbiting around the star. So that's called the Doppler method, or the wobble method. We can also look if there's a star that's pretty bright and a planet passes in front of it, it's going to block out a little of that starlight every time. And we can watch the star get brighter and dimmer, and brighter and dimmer. That's called the transit method. And we'll see some graphs with those. Telescopes are getting powerful enough, or the ones we launch outside our atmosphere can see things clearly enough that we're starting to be able to take direct measurements of watching a star. Remember we talked about this wobbling. Well, if the planet's moving around like this, it's wobbling in it around. It's hard to do, but if the planet's moving around like that, the star is moving in reaction to it, and we can watch the motion of the star. And those are a few of the methods. You'll learn about more of these in videos on the assignment page, the session page. Remember, this is your third assignment where you're going to be looking at some of these techniques we talked about. And keep up with your good discussions. Thanks. Have fun.